Okay, solving limits from a table. So rather than a graph, right, and a graph is a visual representation of all these x and y values that come together, we're not given all the x's as a table. Okay, and if it helps you to sketch the graph, by all means, sketch the graph. Right, do what's best for you and your brain and for your understanding. But as you look at the x values, it goes from -9 to -5 to -3. Right, this is a +4 difference and then a +2. So it's definitely not a linear type of a progression in x, but we really don't care anyway. Right, we really just are looking at the numbers and what they're doing. So at -9, the y value is 513, right? Pretty tall. So it looks like our graph is way up in the, second quadrant, right? -9 is a second quadrant number, and then positive 513. So the graph is coming down or something, maybe, potentially. Right? -5, it's 33. So as we're getting closer to 0, the y values are getting, looks like they're getting closer to something. What do it looks like they're getting closer to as you get bigger and bigger x's? It looks like it's approaching 1. Right? So our minds might be thinking of the limit, right, as x approaches infinity, might be going to 1, as it looks like this is 1.5 and 1.25 and 1.002. Right? And that's all the information that we're given. So we're going to have to make some mathematical assumptions. Right? Not a whole bunch, but some. So let's see. What are we asked to do? The limit as x approaches -infinity. Right? That says -infinity, yes? So what do you think the y values are doing if we were to be going farther and farther to the left of our table? Probably getting bigger and bigger and bigger and bigger, probably getting up to infinity. Right? Chances are, if we're just looking at this table and taking it at face value with the assumptions that we're making, it would probably go to infinity. Now, what about at -3? Let's find -3 as our x. And what is the y value at -3? 9. It's +9. Right? So we're not told what happens a little bit to the left or a little bit to the right. But the y value at -3 is +9, so that's what the limit's going to be. Okay, as long as there's not a hole or not an asymptote, the limit is the y value at that point. Okay, we had a couple of examples from that yesterday with the graph, where they didn't tell you look left and look right, they just told you look right at that point. Right, and that was the y value. What about as x approaches 1? Where's that one? 1.5. It looks like it's going to be 1.5. And then our guess as x approaches infinity off the right side is going to be, right, +1. Okay, and I'm sorry, you really can't see that green very well, can you? I can't see that green very well. Equals 1. Okay, so pretty good if they give us all of the y values for every single corresponding x value. But if we look at example 2, notice there's a whole lot extra things going on here in example 2. Okay, we have a couple of undefined values, if 2 of them. Okay, so 2 ways we're going to have an undefined value: if there's going to be a hole or if there's going to be an asymptote. Right, those are our only 2 points on a graph that are ever undefined, at a hole or at a vertical asymptote. So the question is, how do we tell the difference? Okay. Normally, what's happening on the left or the right side of an asymptote as far as the graph goes? It's normally going up to infinity, right? So if this were an asymptote, right, the graph is either going down to -infinity or the graph is going up to +infinity. Right, so we're going to have really big values or really large negative values of y as we approach an asymptote. Okay, and what about as we approach a hole? Right, what are the numbers doing as we approach a hole? Right, it's going to be a number, right? They're kind of looking like they're going towards the same thing. So if this had a y value of maybe 4 or something, right, this would be 3.8 and 3.9 and 3.92 and 3.94. And then maybe here would be 4.1 and 4.01 and 4.0001, right? Getting closer and closer to that whole value would be the limit at a hole versus infinities for asymptotes. So let's see what we have here. All right, first we're talking about -infinity, so going this direction, right? We're at -1 and then -1,000. So what do you think is going to happen with these y values as you go further and further to the left? If the y value at negative 1,000 is 1.002.
Closer to 1.
Probably closer to 1, right? So the limit to the left of our graph is probably going to be approaching a horizontal asymptote at positive 1, right? That's the best guess that we can make from this data. If we had more data, we might be able to make a better educated guess, but this is what they give us, so this is what we have to work with. Okay, now the next one says, as x approaches negative 1 from the left, right? This little minus sign up here means from the left. So that means we're coming in this direction, right? So we had a y value of 1, and then at negative 1, it was at 2001, right? So it looks like it's going maybe down, right? Do you think there's going to be an asymptote at negative 1? With the left side being 2001 and the right side being, so it's going up then. If the right side is 2000, right, that's a very large value of y. And if the left side is negative 1,999, sorry, I made my graph go the wrong way, right? This is going up on negative 1. So as x approaches negative 1 from the left, our graph is going to go to, it looks like infinity. All right, would you be okay with that graph going to infinity? So what are we looking at? Negative 1 is right here. And what did we say? Positive 1 was right here. So it looks like the graph might be doing something like this so far. So from the left, the graph is going up to positive infinity. What about from the right side? Right? Probably coming down from negative infinity. If it's really close to negative 1 on the right and really negative 2,000, probably going to be a negative infinity limit at the right side of negative 1. So let's go down to f then. Look at f. F said, what is the limit at negative 1? Okay, if the left side goes to positive infinity and the right side goes to negative infinity, what is the limit at negative 1? dne. And right, we don't write equals dne, we just write dne. The limit does not equal, does not exist. The limit just does not exist. Okay, so what else do we have? At positive 2, where is positive 2? Here's positive 2. So on the left side of positive 2 at negative 1.99, we're at 0.333. And then here we're at 0.334. But at 2, it's undefined. So it looks like we're going to have a hole at positive 2, yes? But what do you think is the y value? What is the y value that's in between 0.333 and 0.334? 0.333, 333, right. Something in between there. So chances are, how do we write 0.33333 repeating as a fraction? 1/3. I would say that 1/3 would be a probably pretty stinking good guess as far as the limits of that y value, the actual y value at the hole, right? 0.333 on the left and 0.334, right? So yeah, 0.3335 is in between there. So something, right? Something close to 1/3 might be your most logical guess. And then infinity. So as the graph goes off to the right, what is happening to these y values? This one was 0.333 and then 0.334. And then here at 1,000, an x value of 1,000 is 0.998. So chances are it's getting close to 1, much like our other horizontal asymptote did as x went to negative infinity. Okay, so we had a hole at positive 2 at 1/3, and then looks like the graph continued on going and approaching its horizontal asymptote, right? And that's just a sketch. I really have no idea what those actual numbers are, but that's good. Okay, so looking at a table, we either have continuity, right, continuous and complete, and the limit is the y value at that particular x, Or if you have great discrepancies, right, or thousands of values, right, y values in the thousands, then it looks like we're going to infinities or negative infinities. And if your numbers are getting closer and closer to something in between, then you have yourself a whole and an actual y value. Okay, so those are the things that you'll get by looking at a table and finding the limit from a table.